everyone. My name is David Apple, and I'll be your host for today's webinar. I want to thank those joining us for the first time, as well as welcome back our loyal followers. Today's topic will cover JAMS, HelpSystems' newly acquired enterprise workload automation solution. HelpSystems aligns IT and business goals to help more than 15,000 organizations manage their IT operations, cybersecurity, and infrastructure monitoring. JAMS is their cross-platform solution for managing, monitoring, and securing critical batch jobs and workloads. Our presenter, Kevin, today will share some of the challenges customers typically face as they start looking into enterprise solutions. And then he'll highlight the features in JAMS that help them modernize the way they automate their jobs. Before I introduce Kevin a little bit further and hand things over to him as our presenter, let me take a minute to introduce our organization, Flycast Partners. Flycast Partners, we're here to deliver a truly amazing IT experience. Founded and staffed by personnel who have many years of experience in the IT space, we took the best ideas from these collective experiences and the components necessary to become a leading value-added reseller and process consultant in the North American market. We offer best-in-class implementation services and training in IT service management, IT asset management, endpoint management, capacity management, and IT operations. Our professional services can scale up or down to meet the IT needs of any organization, regardless of the size of the budget or any restrictions you have. We offer services both on-site and remote, as well as training. Our remote administration services will enable your organization to focus on your normal day-to-day operations, saving you both precious time and money. I encourage you to reach out to us at 1-844-FLYCAST. That's 844-359-2278, or simply visit our website to learn a little bit more about us, see our upcoming webinars, and talk to us a little bit or chat with one of our specialists as needed. Now let me introduce our guest speaker today in more detail. Today we welcome Kevin Vliet. Kevin is a product evangelist and director of support services for JAMS, the enterprise workload automation solution from HelpSystems. He has led more than 100 enterprise conversions to JAMS and is an expert on the nuances of scheduling on Task Scheduler, SQL Agent, cron, and many business applications. Kevin has presented numerous SQL, Microsoft, and PowerShell user group meetings on topics such as enterprise security for batch processes, PowerShell automation, and hybrid cloud automation. Kevin co-authored the JAMS University curriculum, a comprehensive training program for training IT administrators to manage large-scale cross-platform enterprise workloads. So what I'll do now is I'll kind of hand over the presenter privileges over to you, Kevin, and we can get underway with the rest of the presentation.
All right, great. Thank you very much, David.
Yeah, my pleasure, Kevin, and I should have the handoff over to you now.
All righty. Started. So again, thanks everyone for joining, and a special thanks to Flycast for putting this together today. I'm Kevin Vliet, Director of Support Services for Workload Automation at HelpSystems. So we'll be talking about a few things today. First, we'll talk about the differences between job scheduling and the more modern term workload automation. Then we'll get into what really drives use cases and the need for workload automation. We'll cover a few of those use cases, and then lastly, we'll talk about those exact use cases, kind of explain them inside of our product JAMS, and get a glimpse at some of the robust functionality that JAMS has to offer. All right, let's dive in. So job scheduling, it's been around since the days of the mainframe. Now, while most of us probably don't need to be concerned with reserving scarce time on a mainframe these days, we all need to find ways to execute critical business processes efficiently over and over again with minimal interruption. Now, the job schedule is the framework for getting work done. A well-defined schedule reduces labor costs, the chance for errors, especially human errors, and ensures a timely start, but not necessarily a timely completion. We rely on stable executions and price scheduling, which I'll explain what I mean by that in just a minute. Now, job scheduling, in the traditional sense, works well under certain conditions. So first, few users are setting the schedule, so there's not a lot of people involved with all of these jobs. Jobs run predictably, so they run at the same time every day using the same resources, and they rarely error out. Jobs are atomic. They run on one system and don't depend on sub-processes on that same system or maybe another system within the environment. Job definitions rarely change, so it's configured, and you set it to run, and you don't have to worry about it too much. And everyone knows what the jobs do, so you don't have jobs being siloed or somebody takes ownership of a job. Everyone knows exactly what's going on in that environment. Now, if you've got these simple requirements, you just want to back up a database at maybe 2 a.m., that's pretty easy. Tools such as Windows Task Scheduler, cron, and SQL Agent work for those simple but happy path jobs. But when it comes to situations where you're a team of 10 people scheduling thousands of jobs, and what happens when 2 of those people turn over in the team? Now suddenly you're dealing with little tasks that normally little tasks are now becoming a big deal within that entire system. So trying to figure out what's going on when certain errors occur and things like that. Now, the modern enterprise defies that simple scheduling. So the word job is much broader nowadays because we use many different applications, platforms, and teams to accomplish the work at the rate that the business demands. Now, many people are leveraging the schedule, defining jobs, executing ad hoc jobs, rerunning jobs. Those jobs are unpredictable. Some have many inputs and take a long time, while others could execute very quickly. Some fail, not because of the job definition, but because of something simple like a network error. Jobs depend on different platforms and applications. So enterprises choose technologies because they match with their business needs, not because they all come from one vendor. Job definitions are updated regularly, often by more than one person. Jobs have varying measures of success. So success for one job may mean completes by 5 p.m. and produces 3 files and updates a variable. So there's a lot in play with some of those more complex jobs. And are these the things that first come to mind when you're scheduling a job? Probably not. And they are things that have a significant impact on your jobs? Definitely. So that's why we focus not only on scheduling, but on automating. Now, workload automation ensures that enterprises aren't just putting jobs on a timer and hoping for the best. That's kind of what I mean by price scheduling that I mentioned before, where you might have let's say you have a job that depends on a file transfer, pulling a file down before it runs. Under price scheduling, those would be running under 2 different scheduling applications, and you might schedule them far enough apart where there's a good chance that they're not going to overlap. But what happens if a large file comes through for that particular day and that download runs long and overlaps with the job that needs that file? All of a sudden, that downstream job is going to fail, and that price scheduling didn't work out so well for that day. So workload automation puts every critical business process on a path to success, no matter how convoluted each path is. An enterprise solution combines each unit of work, i.e. the job, with all of the configurations necessary for it to execute successfully, all while following the rules of the business. Note that last part about business rules. There's a lot of workarounds to push jobs through to a schedule, giving users admin rights, storing passwords and scripts, provisioning more resources than are really necessary on a VM, just in case. But all those workarounds have hard costs. Ignoring regulatory requirements, squandering IT budgets, and risking security is no way to automate or run a business. Now, enterprise IT has goals and constraints. These are the driving principles behind enterprise workload automation. So we see four main drivers of workload automation initiatives: reliability, sprawl, security, and failure cost. Now, as for reliability, we automate to improve productivity. It frees our minds of worrying about those tasks, but only if those tasks execute reliably. Businesses typically encounter two types of reliability issues. The job doesn't execute, or worse, the jobs appear to have succeeded, but the actual job itself never ran, the source never ran. Both are unacceptable for our most critical jobs, and enterprise workload automation solutions such as JAMS employ a host of features to ensure jobs execute successfully, adjust to conditions outside of the job source, and return the correct status. Now, having more than one application for the same task is a telltale sign of inefficiency. So one department could be using Windows Task Scheduler, another uses cron, another uses SQL Agent, another uses a different instance of SQL Agent. The list goes on. So, take an inventory of all of the scheduling tools in your business and ask yourself, why do I keep all of this separate? Does it give me an advantage having all of these tools, each of which works a little differently, or could I be doing this better? Jobs and workflows are valuable corporate assets. They may not be private corporate databases, but they often can access private corporate databases. Their source can reveal a business's special sauce. Their execution can affect millions of critical transactions. They need as much protection as secure databases. Now, when workflows fail or stall, businesses incur a cost. It could be a hard cost, such as the SAP order process failed, so we paid $1.10 more than we should have on some material, or it could be a soft cost, such as Steve, one of our lead developers, just spent 2 hours trying to figure out how to resubmit our individual franchise sales to the general ledger. Neither of those are a good situation to find yourself in. Now let's talk about a couple use cases. In this first use case, we're talking about 50 SQL servers that all need to run a monthly report. So at the end of the month, we need one metric on how reliable our ETL processes were. So this same job runs on 50 different SQL servers throughout the month, and we need to log into each one separately in order to obtain the logs to build our report. So furthermore, when one of the SSIS packages fail, we have to log into each server separately to find that particular failure. So there's a lot of human intervention involved with gathering that data, and then not a lot of visibility. Second use case, multiple people contributing to a global workload. Now, our nightly branch reconciliation process involves 4 people. Our application developer writes and updates the source. Our head of IT ops determines when the job should run. He tests it and promotes it to production. Our CFO needs an alert if the resulting file will miss their delivery time. And our support team is on call all night to troubleshoot the job if something goes awry. Each person has a distinct role, and we can't just give them all admin privileges. So how do we solve that problem? We need a tool with security that can be defined at a very granular level, all the way up to the top level. So whether it be at the individual job, maybe a folder structure within a certain environment, or the entire infrastructure environment itself, the server. The next use case would be, what happens when someone leaves the company? So jobs that an employee created have been running successfully for years. Nobody really has to think about them. But then suddenly, the expected output from those jobs stops coming in. So the person who created the cron job is now gone. So how do we figure out what's going on? We don't know what changed. We don't know where to find the source files. We don't know how she kept the job running for those 10 years while she worked for us. So had we been storing the job definitions centrally, managing them with version control right within a scheduler like JAMS, problems like this could be avoided. So the next use case would be multiple calendar requirements. So a lot of times, companies are global companies, and we have to manage all kinds of exceptions within scheduling jobs, whether it be U.S. holidays, UK holidays, corporate fiscal years, government fiscal years, blackout periods. I mean, the list goes on. So how do we neatly fit all of our jobs into those calendars and then manage them efficiently the way that we operate? So the solution to that is custom calendars. That's something that JAMS offers extensive capabilities in, and really allows you to dive in and explore the use of things like natural language inside of JAMS, which is something we can talk about for scheduling your jobs, and then also creating those custom calendars similar to the screenshot that you're seeing here, and then manage them efficiently. So those are some of the big use cases that we'll talk about. So what we'll do now is I'm going to flip over into the JAMS application, and we'll go through some of these use cases as well as some of the critical functionality that JAMS has to offer. So we'll talk about and cover things like reliable job execution, making sure that jobs run when they're supposed to under the correct conditions, and that we can kind of work our way around those varying conditions that aren't necessarily directly tied to the job itself that runs. So whether it's an upstream or a downstream dependency, we want to make sure that everything runs when it should, how it should. We'll talk about consolidated management and monitoring. So when you have an application like JAMS, you're able to see everything running across all of your platforms and all of your applications in one centralized view, as well as interact with it without having to log into each of those 50 SQL servers that we mentioned before, or maybe logging into a Linux server and pulling up cron so that you can see what's going on inside of that application. Everything is stored directly in JAMS. You have that great visibility as well as the ability to interact with all of those jobs, even though they're spread out across the environment. And not only that, but we have a way to lock it all down too. So with our robust integration with Active Directory, you can set very strict rules and policies around security to make sure that the appropriate groups of people or individuals have access to only certain areas or only certain jobs within JAMS, so that somebody in one department would have access to their objects, but not another department's. And then within that department, you can set different roles as well. So, all right, I will go ahead and I'm going to switch over to the JAMS application and we'll talk about a few of those use cases. So pulling up the application, the first thing you'll see here is the home screen. So this is where you've got many common activities for doing things within JAMS, whether it be creating a job definition, everything from simple Windows or Linux or SQL jobs to what we call sequence or multi-step jobs, which allow you to really branch out and kind of tie multiple processes together. So if I have a file transfer that needs to run before a PowerShell or a shell script runs, I can tie them together with a job like a sequence job. I can edit jobs, I can submit jobs to the schedule, and then I can create all of the other various objects in JAMS, which we'll touch on briefly. Over on the right here, we have the Explore JAMS section. So we can talk about all kinds of different job types or execution methods, as we call them within JAMS. So if I open up, and let me pull that over to the other screen. We can talk about things like an SSIS job. So if I have a specific SSIS package on SQL that I need to run under certain conditions, I can call that within JAMS with a very simple fill-in-the-blank form using a connection string to that SQL server. So rather than building it out and say SQL Server Agent, I can call those commands directly. Now, speaking of SQL Server Agent, I can also convert and run my SQL Server Agent jobs directly from the JAMS application. So directly in the JAMS client, you actually have a native conversion utility that ships that allows you to convert those tasks from those common applications like SQL Server Agent or cron or Task Scheduler. Those are all tools available to you to help you as you migrate into JAMS. So if we jump over to the monitor view, we see we have a couple processes and jobs running right now. So this monitor view gives you a holistic overview of everything going on inside of JAMS. So jobs that are waiting for their execution time, jobs that are holding until they are manually released. So you can actually interact with your jobs as they're running. So this job was scheduled to run. Now, if I wanted to right-click and release this job, actually interact with it, I have the ability to leave an audit trail comment, released for Flycast. Let's go ahead and let that guy run. Now he's going to go ahead and execute, and you see that he executed successfully. You've got recently completed jobs, jobs that are currently executing. So everything under all of your applications and platforms, whether it's on Windows or Linux or mainframe, everything is consolidated to a single pane of glass, and you can track, manage it, and interact with it directly within this monitor view. The history view gives you another view of the ability to go and look back on jobs that have run within a query. So I can query back as far back as I want. But as you see here, it looks like we have an issue with his daily table load. He's been failing pretty regularly for the past few hours, so we might want to look into that. So I can double click and look at the log file. And here we see that there looks like there's a bad command in here that's causing the job to fail. So I might want to go and look at the source code for the job and debug what's going on there. I could look at a successful job and pull up the log file here. Again, lots of visibility within all of your jobs. So as these execute, you get a unique log file to track the status of everything that ran for that particular job. So this is just doing a basic SQL query. So moving on, let's talk about some of those use cases now. So the first one we'll talk about, what happens when somebody leaves the company and that job all of a sudden starts failing. Now, under normal conditions, you wouldn't really, you might not know where to look for that particular job. This was set up by somebody, the person that left, and it always ran when she was here. And now all of a sudden we're having issues. We don't know, where do we start? With a product like JAMS, everything is centralized. You can use tools like that history view. We have custom alerting, so people can be getting email alerts and even interactive alerts through some of our other integration tools to get you, alerts, text message, and phone calls on your cell phone for those critical processes should something go awry. So there's a lot of great tools within the product. But right now we're looking at a basic a PowerShell script that just does a SQL query for you. So the source code can be stored directly in your JAMS job. You can come into here. You have version control to see a list of changes between them, so you can actually compare versions. If I compare these two, I see them side by side. So I see that the description has been updated. I also see that some parameters were updated. And then I can see actually if the source had changed between, you can compare the source code itself side by side between those versions. You know exactly who made those changes, when the change was made, and what the current version is. That's not something that you can do if you're storing this PowerShell script in a PS1 file and calling it with a Windows Task Scheduler job. And also what happens when that PowerShell script or that SQL query needs to run on multiple environments. Now you've got multiple versions of the same source sitting and isolated in multiple environments. You want to be able to pull that into one spot and manage it centrally. So that's a very simple use case for just a very basic single-step job using a PowerShell script. So what happens when we want to start pulling them together? I have multiple processes, multiple PowerShell scripts, or maybe a PowerShell script and a file transfer that are dependent on one another. How do I kind of make them see one another? So I can do that using a sequence execution method, a sequence job. This gives me the ability to have control flow objects so I can tie them together. So looking at some of these gray tiles here, these represent individual job processes that I'm tying together with things like a sequence container or a parallel container. So not only can I run them one after the other, but I can run them and ensure that when this backup database completes, I can go ahead and start download web to file and check database immediately. Once CheckDB completes successfully, I can also go and then execute a database query on the JAMS database. That query can be defined directly in here, so I can just paste my SQL query right inside of the test. I don't necessarily have to create a job to perform that. It's all done directly within the sequence. So once these two jobs complete, JAMS database query and download web to file, I can then proceed on to the next parallel activity, which is going to extract some data and then also process other SQL data. And when all of that is done, the last step is to import that SQL data back in. So this is a great use case to explain how we can tie those jobs and processes together in a relatively simple orientation. Again, we covered audit capabilities for your job, so you can compare the source code between different versions of the same job. It's not just for that PowerShell job that I touched on, it's for any type of job, whether it be SQL, PowerShell, Linux, sequence like this, it's all capable of that audit functionality. But next, let's talk a little bit about security. So how do we lock these objects down within JAMS? So we've got pretty robust security capabilities within JAMS. So as you see, my user right here, because I was the creator of this object, I'm automatically going to be granted full access to the object so that I'm able to go back and edit my own work. But then we can also set up inheritance. So if I minimize and shrink this down a little bit, you'll see over here on the left, I have a folder structure that mimics sort of like a Linux file system where you've got a root folder up top and then subdirectories beneath it. All of these folders have properties and security that can be set on them, and you can also set an inheritance structure so that you can easily manage things like security or what server do all of these jobs run on, or what credentials do I authenticate with to ensure that this runs under the correct permissions. So looking here, I've got various inherited ACEs, access control entries, that were being defined on the root folder, folder above. So looking at the job definition right now, so as I click through, if you look through these grayed out boxes, you'll see that different boxes are checked based on the group that I'm defining. So if one end user is in the JAMS developers group, they're going to have higher access to an operator. So maybe a NOC would be defined under this operators group. They would have security access to go and submit and monitor any job within this accounting folder. They could look at the history view. They could cancel the job if something were to come up, and they could restart. Whereas, say, an inquirer, somebody who just needs read-only permission, would just be able to look at that job in the monitor or maybe run a history query and look at the log file. But if you didn't want somebody to see the details of a particular job, you would simply omit them from this list on the object, and whether it be inherited or defined directly on the job, and they wouldn't be able to get any of that potentially sensitive information out of the job definition or the history record, the entry itself. All right. So we talked about sequences, which allow for a fairly streamlined approach to tying your jobs together. But what happens when you have complex business logic that has to be built in to your workflows? That's where the workflow execution comes into play. So this is an alternative to the sequence job type. Now this is a very robust editor that allows you to not only tie your jobs together in sequences and parallels like we saw in that sequence execution method, but we also have the ability to pull in control flow logic. So we can put in if statements, do whiles, for eaches, as well as countless other objects that are available to you over here in the toolbox on the left-hand side. So everything from big data, we could pull down files, we could send emails, we could zip up files, we could encrypt and decrypt. The list really goes on. There's a lot of functionality within these workflow jobs that allow you to not necessarily have to script in some of that business logic. So if you're not necessarily great at scripting in a certain language, maybe it's Shell or PowerShell or anything, you can do that all pretty easily directly within the workflow execution method without having to script. So again, another great tool and avenue for getting that business logic into workload automation and being able to control all of your jobs and ensure that they run correctly under all of the conditions that you need. So that is a high-level overview of those use cases. Oh, I'm sorry, I had one more for you. So let's talk quickly about some of the complex calendaring that we have within the product. So JAMS has the ability to create custom calendars. So if you need a holidays calendar in the US versus the UK, that's very easy for JAMS to accommodate. But let's say I need to put a schedule on this job, and I need it to run every other Tuesday. So I'm just going to go ahead and I'm going to run this job on a schedule. Now, JAMS can understand things like every other Tuesday or last day of month minus 3 work days. And that's possible through the use of natural language inside of JAMS. Natural language is something that we've developed to be able to specify things like that, so you don't have to manage a custom calendar for all of those unique scenarios and then maintain it and keep it up every year. Keeping up a calendar for every other Tuesday would be time-consuming and inconvenient, so this makes it very easy for you. One thing I'll note is that JAMS can actually validate what you are putting at it. So if I just take the K out of workday, JAMS will tell you that it's unable to evaluate the date. That means you're either telling it something it doesn't know, or maybe you have a typo like I just had. So you can go ahead and correct that and save it out. Schedule time, maybe I want this to run at 2 a.m. on the last day of month minus 3 work days. So I can finish that, and you're going to see it added to the schedule. So I can do this with as many schedules as I need. So oftentimes jobs have very unique schedules based on the day that we're talking about. So on Mondays it needs to run at 2 a.m. and Thursdays it needs to run at 4 p.m. and 6 p.m. That's very attainable with multiple schedules and custom calendar functionality within JAMS. So all of these things, ensure that your environment and your jobs are reliable. We keep them centralized. We secure them with security. And we also are saving costs, both hard and soft costs, and giving you peace of mind. So I hope that this demonstration and overview of JAMS and workload automation has been helpful for everyone. That is all I have for you guys today. Again, I want to thank Flycast partners for putting this together, and thank you all for joining us. If there are any questions, we would be happy to take those at this time. So, David, I'll turn it back to you to see if there's any questions.
Yeah, interesting stuff, and thank you so much, Kevin, for the presentation. For anybody on the line, there's a Q&A session that you're able to type in. So if there's any questions, please feel free to send them over. We'll read them out loud for Kevin to answer or to elaborate on. And right now, I don't see anything popping up in the Q&A section, Kevin. We'll give everyone just another couple seconds if they have any questions. But if anybody does have questions after the event, definitely reach out to us at info@flycastpartners.com or go to our website and chat with one of our specialists, and we're happy to get back in touch with you with those answers. So Kevin, I don't see any more questions popping up. So if that's no other questions from the audience, I want to thank you again for coming in and talking to us a little bit about the new solution with HelpSystems JAMS.
Thank you very much, David. I appreciate it. And thank you, everybody, for joining today.